The topic that we are going to talk about today is how to choose among projects when resources are limited. In previous videos, we talk about the MPV decision rule for standalone or independent projects. We said that we should accept a project once its MPV is positive or larger than zero. So, in an ideal situation, we would accept all the projects with MPV larger than zero, or we would accept all positive MPV projects. But in a real world situation, this might not be true because our resources are limited when we cannot take all the positive MPV projects. For example, let's say Amazon may have 100 projects to invest, and all these projects have positive MPV. However, the resources that needed as an initial investment for this project is about $10 billion. But Amazon has only $1 billion to invest in these projects. So Amazon should figure out a way to allocate its resources between these projects in a way that the value that is created for Amazon shareholders is maximized. So the highest possible MPV from this combination of projects should be achieved. Okay, so in this next slide, I'm going to talk about example to clear how we can choose among projects when resources are limited. So consider a firm that has a limited budget of $100 million. The CFO is evaluating 3 projects with following initial investments and NPVs. Okay, what project or project should be chosen? Okay, so if we want to choose the highest MPV project, we should go with project A. Notice here that project A, B, and C are not mutually exclusive. The question or the example has not said that these projects are mutually exclusive. So if I choose project B, it does not prevent me to take or do project C as well. So I have another option to do project B and C both together, as long as the initial investment required for these 2 projects is less than our budget of $100 million. Okay, so the initial investment needed for doing B and C is 60 plus 40, which is $100 million. And their MPV of doing B and C would be equal to adding the MPV of B to the MPV of project C. So 38 plus 35, which is 73. So now see that with the same amount of investment as project A, $100 million, we are getting a larger MPV as we were getting if we were only doing project A by itself. So if we choose project A, there is no money left to invest on project B and C. But if we invest this 100 million budget on B and C, the total MPV that we can get from doing these 2 projects is larger than the MPV given by doing only project A. So the answer to this example is that we have to we it's better to take both project B and C. We would not choose the project with the highest MPV because their initial investments are different. And if we do B and C, we are getting a larger MPV rather than doing project A alone. So the takeaway from this example is that when you cannot undertake all possible opportunities, choosing the highest MPV project might not lead to the best decision. So what is the solution in this situation when our resources are limited? So there is a measure called Profitability Index that can help us identify the optimal combination of project that would create the maximum MPV or the maximum value for the firm and its shareholder. Profitability index is defined as the MPV of project divided by its initial investment. So we want to see how much MPV is created based on per unit of resources consumed. Okay, so for example, let's say if my MPV is 100 and the initial investment was 200, so the profitability index is 0.5. This means that doing these projects creates 50 cents MPV or 50 cents in NPV terms for every dollar invested in this project. Similarly, if the resource that we were considering was a number of engineers or number of hours that we spent doing this project, we could also interpret it in a similar way. Okay, so now let's solve a problem to see how we can use this profitability index to find the optimal combination of projects for a company. Aramco is considering several projects to undertake. All of the projects currently under consideration have a positive MPV, but Aramco has a fixed capital budget of 300 million. The company does not believe that they will be able to raise any additional funds. So again, the budget for investing on any available project is limited to $300 million. How should Aramco prioritize the projects that are listed on the next slide? So here are the seven projects that are available to Aramco. Each project has its initial cost in the second column and its MPV in the first column. So calling these the first column and calling these the second column. Okay, so our goal here is to maximize the total MPV we can create by investing $300 million as initial investment. The way to solve this problem is I would create another column and call it profitability index. So I would calculate the profitability index for each of these projects, and then I would sort the projects based on the highest profitability index. So the highest profitability index will be my first priority to invest, and so forth. Also, I would have a column which I add up the initial investment required for each project. So once that I reach this $300 million budget, I would stop picking up projects because we have no more money to invest. So here you can see that I already calculated the profitability indexes for these projects, and I have sorted the projects based on the profitability index. So project G currently has the highest PI. And then in the last column, I have cumulative initial cost or cumulative initial investment amount. So I would stop at 300 million once this cumulative initial cost adds up to 300 million, because after that I have no money left to invest on these projects. So by doing so, I can choose project G, A, F, and C. If you try to find any other combination that can create the MPV as high as the MPV that we are calculating here, the profitability index would be useless. So my point here is that the combination that is given by sorting out projects based on profitability index is the best combination of projects to take. This would maximize the total amount of MPV that we are getting from doing these projects. So the answer to this question would be to take all these first 4 projects that are sorted based on the PI index. Okay, so the next thing is there any problem with the profitability index? Unfortunately, the PI index does not give an accurate answer all the time. And by all the time, it means that if there is more than one constraint in the problem, the profitability index might not work very well. What I mean by constraint, it means, for example, I have $100 million as the budget of the company, and then maybe 50 engineers to work on those projects, and the hours that allocated to doing those projects is only 500 hours. So if in this case, when I have 3 constraints, the profitability index would not work very well. And what would be the solution if we have more than one constraint in a problem? The solution would be to solve an optimization problem. We need to, first of all, write an optimization problem with all proper or appropriate constraints that we should consider. And then we need to try to solve that optimization problem, which is out of scope for this course. So to sum up, we see that if we face limited resources, if the company has limited resources, we cannot accept all positive MPV projects, because the initial amount of investment needed for those projects might be higher than what a company has available to invest on those projects. So in these situations, we should calculate the profitability index for these projects and sort the projects based on the profitability index, and invest on those projects that are ranked the highest in the profitability index.